Okay, so there's your basic circuit. Now you can see that this test point THT is actually green in colour. It means it's got a defined footprint already. So I know what size shoes it wears. I know what colour clothes it's wearing, okay? But if you look at the resistor, it's black. Now that means that it doesn't, I don't know what its footprint is. That seems a funny thing to say. It's a resistor, right? Well, you could have a resistor that big, you could have a resistor that big, you could have a resistor the size of a grain of sand. I've got to tell the machine actually what they are. Now this is where things get really quite interesting, and everyone has difficulty in doing this. But what I'm going to do is I want to define the footprint of that resistor. So I'm going to click on it, and then I'm going to click on it. Then I'm going to go click on it, right click, and if I go right to the bottom it says properties. And I go down to properties. Okay? Not too bad for the moment. Lots of different options there, the label fields display, people have changed the values and the labels on it and so on and so forth. But you haven't tried this option on here, which is edit package. Now when you go to edit package, there's a series of options here, and at the moment it's saying select from database. Well, that's fine. And we can just say, well, it's got 2 input pins, it's single package, all the rest of it. We're not interested in that, we're just going to click OK. Sorry, I'm going to click select from database. And when I select from database, you'll see that there's lots and lots and lots of different footprints. Look at all these, look, thousands and thousands of different footprints that I could adopt for my component. I could. Now look at the scroll bar on the right hand side. Look how when I'm scrolling down it makes no difference. In other words, there must be tens of thousands of footprints in there. So how on earth am I ever going to find one? Well, one I could do is I could just say, well, I'm looking for a resistor. So let's just D, E, F, G, Q, R. So I've got something that looks a bit like res. So I could do that. Oh, that looks like a resistor, doesn't it? So I'm not going to show you how to use the filters at the moment, but that looks like a resistor, okay? So res 1500, 900 by 250. It's got TH next to it, which means it's through hole, which is good. So I'm going to choose the 1500 one. I'm going to select it. I'm going to say OK, OK. And you'll notice now that R1 has gone blue. I'm going to show you a much better way of doing this in a minute, which is with filters. But you'll notice that R1 has gone blue. Now if I go to the other one here, I can go through exactly the same procedure. I can go to properties. I can go to edit package. I can go to select a database. And I could do the same trick that I did before, where I could just scroll down where it says package, and I could look for res, which is actually what I'm going to do now to keep life nice and simple for all of us for the time being. So PQ, so res, and I'm going to go for 1500. You don't have to choose 1500, you could choose a different one if you wanted. But it's 1500 microns long is what that means. So about 15 millimeters long. Going to select that. OK to everything. And finally you'll notice that both those resistors are now blue. Now right here on the other side of the footprint to it, I might have made a mistake. I might have made one footprint bigger or smaller than the other. We'll live with it for the time being, but I'm fairly confident I've done that correctly. So now I've got a circuit where the footprint is defined for the connectors. It always is, because there's only one type of connector at that time. But the resistor has a lot of options. So now I'm in a position where I can make a PCB out of this, because all of my components are either blue or green. If they're not blue or green, you can't make a PCB. It'll give you an error. Okay, So I'm going to do save, because otherwise the next step it will say you haven't saved your design. Okay, so it'll catch you out anyway. And the next thing I want to do is I want to do transfer to Multiboard 14.2 and click on it. It's going to ask me what I want to name my Multiboard design. I've got no imagination, so I'll call it design 1, just like I did before. Remember that you must save as your M drive or your USB drive or whatever you want to be. So then comes up a series of options. So we're now in Multiboard. You'll notice it looks different to Multisim, but all the colours and so on look fairly close to what you're used to. So here we are in Multiboard, and it's giving you a whole series of information, but with no options really. I mean, you can click on the view if you wanted, but you're not going to do anything, and you're just going to say, OK. And lo and behold, look what you've got. So you've got a drawing area, and what looks like 2 resistors and what looks like 4 I/O. Okay? Now the first thing I want to do with those devices which are there is actually make it into some kind of circuit. So if I go in and I click on the resistor, not the label of the resistor, I click on the resistor, so I click on it and I drag, I can bring it into the drawing area. So I'm just going to do that quickly with all the components, and then I'm going to think about laying them out in a sensible order. So I click on the components, drag, yeah, that's going quite nicely. Can't get that straight, so I'm not even going to try, I don't think. Let's try dragging this one into the drawing area. Okay, I'm just trying to maintain neatness, so I think I need to flip that one upside down. This is just down to personal preference, okay? So you do whatever you want with them. But you'll see that when I finish with this, my circuit will look something like it did in the original drawing. Okay? Still not happy with that, let's carry on. Drag that in. And finally, drag that one in. Okay, I can do whatever I want with these components now, so I can drag them about. Let's put the 2 resistors next to each other. Let's put this I/O pin over here. Let's just rotate this one anti-clockwise. That's better, that's what we're trying to do all along. Okay, so there's my potential divider that you're used to seeing, and it looks similar to what it did in the main drawing before. Yeah. And just drag this one here. Okay, that's where I want my components on the board. I can carry on playing, and this becomes an art form after a while. You could spend hours and hours and hours getting things right so they look nice. But this is very rough and ready, just a couple of minutes to do that, okay? So that's where I want my components. Now what I can do is I can do auto root and start resume auto router. And something funny has happened, look, because the tracks have gone green. Well, I don't actually want that, because green means, if you look down the left-hand side, it says copper top, copper bottom. So that's actually a 2-sided board that's rooted at the top. I don't want that. What I'm making here is a single-side board, and I only want the copper on the bottom. So I'm going to highlight the copper top down the left-hand side here, and I'm going to auto route again, and I get nothing because I need to copper areas copper top on, so I want to turn the copper top off, and the copper bottom is on, and I did that under the copper layers section at the bottom there. So now let's try auto routing again, and you'll notice now the tracks are red. That means if you look at the legend down the left-hand side, look, copper bottom is shown as red, but that doesn't look very much like a copper track to me, because it looks like it ought to be a lot fatter than that, right? If I did make it that thin and we tried to send it off to PCB way, chances are it would come back and it would be completely dissolved and the track would be broken. So let's see if we can thicken that track up a little bit. So feel free to go down the options which are along the bottom here and just have a look what different things they do. So parts, group parts, nets. So it's actually the nets part that we're interested in here, and I find this really difficult to work on unless I drag the bottom up a bit and make this window at the bottom a bit bigger. Now you've got here max width and you've got min width. So the dimensions, the Americans wrote this, so this is in microns. And their microns are millionths of an inch. And that's a really strange measurement for us as Europeans, right? But get used to it because you will need to convert between one and the other. Now we call microns millionths of a metre, right? But just get used to those kind of measurements. And most of what you see in Multisim will be like that, so you'll be doing a conversion, there's some online converters, so that you can actually picture what size something is. Okay, so we've got our nets here, so the min width, what I can do is I can click on the min width, and, well, I can just change that. So I don't want the min width to be 5, I want it to be 50. Let's see what happens if we do something as bold as that. So now look what happens. You can see that a net is a single set of interconnected copper pieces, because I touched one net there and suddenly that's a big fat wide net, right? So let's do that to some of the others. So I go to this one and I type it